Hello everybody and welcome to this Fusion 360 modeling tutorial in which I'm going to show you how we can build this nice ramen bowl design with surface and solid modeling. What is interesting in this exercise is that we will work a lot with scans. We have multiple scans of the lid, inside and outside and open. We will make plenty of use of the section cut. So when designing, we know exactly how the pieces will fit together. And as a nice bonus, we will go into materials, for example, the three-dimensional wood. And then I will show you a nice way how we can use the move and rotate command to visualize how specific elements, for example, like the lid, could rotate. Very good. And with all that said, let's do it. Let's get started. I'm inside Fusion. I have the supplied demo file Ramen Bowl raw open. The download link to that file is in the description of this video. We have a folder with 4 different scan objects. So the pot is basically just the base, including the handle, as you can see. Then we have the lid closed, we have the lid open. The difference is clear. Here you have actually the smartphone holder and the air vent flap is closed. Here it's open. And then we also have the underside scan. Cool. So how do we start? Let's turn lid open off. And our best friend in this scenario where we have to redesign an object based on a scan is actually working with section analysis. So I click on this plane here. I might have to flip the orientation. There we are. Very good. So we do see now actually all the material thicknesses plus minus. Cool. So we have everything what we need. In the left view, I will create a sketch. Then with the line command, I draw a line straight up and over and down and back. Very important is they all have to be horizontally and vertically aligned. In this case here, I use the perpendicular constraints. Very good. Right click, okay. Then I will match plus minus roughly kind of like the height and width. Let's say somewhat like this. Then we can make this 94 and this one we make 74. This is a pretty coarse scan. We don't have to be and we cannot be very precise, but this is enough to get us or to give us an idea what to work with. Then we can select these 2 lines and make them construction because that's all they're doing. Okay, very good. So with this already done, we can then go into surface mode, go to revolve. I will select this and this as a profile, and I will select this as a revolve axis. Beautiful. This lower edge, we will now fillet. And I can just push and pull this till this seems to match. That looks good, but I would like to have a nice smooth transition. So I go with a G2 design and let's say like this. Very nice. So I have now actually the outside surface. Pretty good. Right click onto that sketch and edit it. And I'm going to add another horizontal and vertical line. Right click, okay, to stop the sketching. This I will bring over. This will go down and I can then specify. Maybe this has 15 millimeters and this, let's say, is 7 millimeters. So the wall, and then here is the main pocket. Because we do have a bigger base and then it's an air insulated vessel. I can turn this one off, finish the sketch, go back to revolve. Then I select these 2 profiles, select this axis. There we are. I can select this edge, go to fillet, and then I have to fillet this a little bit. What I have to pay attention to is that this is not necessarily getting smaller to here. So I see that basically when these two lines match up, we have here a consistent distance, and then from here to there, that distance gets bigger. Or to be a little bit safer, we can put that to there. Cool. Okay. Let's turn the section view off. Beautiful. Let's go to loft, and we loft this opening part. Okay, that is quite nice. I do not know where they came from. Bye-bye. And we have here 3 open surfaces. You see there's just air inside. Let's turn that into a solid so we can stitch this with the stitch command. Pretty good. Click OK. Very nice. Good. And to simulate the materiality, for example, we can go ahead, go to left view. I will go back to this first sketch. There is a seam, and I will just create here a horizontal line, and that line I would like to let's say be 5 millimeters. Does this match? A little bit, let's say 6 millimeters. Okay, beautiful. Now you noticed after we did the stitch, we got a solid body. What I can do now is, as a prototyping idea, select this face and split it by this line. See, this line turns into a plane. There we are. These 2 edges here I will round 2 millimeters. Okay, let's say 3 millimeters. That's maybe too big. 2. Okay. 2.5. All this can be played with later. There we are. Very nice. Okay. The reason why I did a split here, if we press A, you will get the materials I created for this design. Paint enamel, steel, and then we have 3D wood. I can apply this stainless steel to the whole body, or the painted enamel glossy, but the inside is actually a metal. So we keep this at metal, then we switch to face, and we say, hey, that is, and that, and that, that's all plastic. So you see, this is a very economical way to very quickly simulate this volume. We don't really take much care of the inside open space. Yeah, okay, very nice. So let's say we talk to the design engineer, this is all good, and now we would like to further refine actually our design. To shell it, how do we do this? We can go to solid, go to shell, then I select the whole body ideally, and we give this a thickness, let's say 1.5 millimeters. Cool. You see now the whole inside got hollowed out. Pretty cool. And we also would like to have where these 2 materials are, split actually this body into 2 pieces. How do we do this? Well, we still have this line, and now we use this split body command. And we say this body split by this line. There we are. Now we have 3 bodies, and we simply go to combine and say, hey, this inside and that lip join back together. Keep tools off. Now you see we have these 2 individual pieces. Very good. We can go back to the material, pressing A, and simply overriding everything to be only plastic or metal. So this was kind of like a quick demo in how you create first a solid, play with it, and then we do the more detailed part like the shelling. this bowl has a small lip basically to sit on. So I'm going to add this to this first sketch. And yes, when we go to this first sketch, we don't see anything else. That is fine. We can adjust that later. So I created 1 millimeter by 5 millimeters, kind of like a base. Exit the sketch, I can see where it is. I can move this around. So here it would be under it, for example. It's because that fillet, or actually the fillet stops there, you see. So we have to be careful. So maybe here. But what happens if we put this to a little bit there? Let me show you. Now you see there's a little gap. So this sketch profile, we will now revolve around this axis. Because we have section cut turned on, you didn't see the other half, but there it is. And there is this tiny gap. So what I can simply do is I select this gap, extrude, move this one very gently up till it starts to join with the other piece. I turn section cut on again, so it's very easy to see what I'm doing. Nope, there, flop a little bit higher. In your body, you can see how this intersects. So this is a nice overlap. Perfect. This is actually one part. See, very easy. Okay, so kind of like the main bowl is done. Let's take a look at the handle. How do we do the handle? It's pretty easy. It's in your part, so I would suggest making your sketch as an idea. This looks like a rectangle with rounded ends, so rectangle. There we are. I will lock maybe 1 point so I can rotate it, but I have all these horizontal vertical constraints which I need to remove, and then I replace it with perpendicular constraints. We only need 3 in a rectangle, and then I can rotate it. There you see. So that angle seems good. That's the width. Maybe we unlock this one. Okay, this needs to be dimension aligned. Let's make this 18, nice and clean. 83, very good. We're creating a very quick concept. We suggest where intersections, mechanical connections elements are, etc. And because this is a row of body, I need to find the midpoint there. So what I can do now is I select this profile, I select this midline I created and go revolve. There, beautiful. How long is this? 18, and then I can select these 2 body edges and fillet them 18 divided by 2. So I can also write 9. Diameter divided by 2 is radius. Radius what we need for the fillet. How do we do the connection now? Sure, we could make now, if we want, another piece because it's another body, just as an idea. And we do a horizontal line there, a straight line down, kind of like angled straight up. Very good. Yeah, this looks kind of fine. Plus minus, that is good. And then we go to solid, extrude. We want to use the thing I can't say, symmetric. I always want to say symmetrical. And then we push this one out by, I would say 6 millimeters. If we turn off section analysis, you will see the scan is a little bit moved to the right side. So this is all good. So we did extrude this 6 millimeters, and these top surfaces I want to make to be nice and round. So we do this with the fillet command. So 6 here, because we went 6 each side. So 12 divided by 2, 6. Beautiful. Look at that. Nice. What we can do now is this. I could, for example, if we would drill this on this piece, simply say replace face. So this face, fold over that face. There we are. Right click, isolate. You see how this has a very gentle arc. Right click, unisolate. And technically speaking, we can do the same there, or we can see what happens if we are extending this. So this could, for example, grow in there. I don't really know where it is, so we'll switch to this view. Let's say to there. Yeah, so we can, for example, from the left side slide it on. Yeah, that makes sense. That could work. So let's say 10. And then I say from this, I would like this to be removed. But hey, please keep that piece. Thank you. So that's there. And whoops, that was the wrong one. There you see how we cut that hole in there. But now I realize, oh, that doesn't actually fit in there. Good luck jamming a bigger end through a smaller hole. So this is another good example where sometimes you have an idea, you try it out, and then you realize, yep, doesn't make sense. So what can we do here? Well, let's do the same. We simply fold this one over that cylinder. But now from the right side, we could make a hole and put a screw in there. Okay, so we have this piece. I could right click and edit, and then I see exactly where this is. And here horizontally, I draw a nice rectangle. This has to be horizontal at least. Interesting. This perpendicular. Oh, this is perpendicular to here. So sometimes I like to clean this up more. There we are. Press D. What's the opening? 3 millimeters. 12. I mean, it doesn't really matter as much. And why is this useful? Because now we can select this and this edge and do a revolve. You see now, there we cut through. Because we have this view on to see hidden edges, I can now go ahead, bring this over. So that's there. And if I press M, I move this over. Right click, repeat. Oh, that's kind of cool. It actually did not really finish that command. Why do you sketch elements? Okay, I guess this one doesn't want to do it as much. Oh, I'm actually a little bit silly. This we dimension to 12, so let's delete it. Now I can push this in more or bring this further to there. So it's not too much of a hole. Very good. Let's press A. This is plastic and this is three-dimensional wood. For those who do not know it, when you go to Fusion Materials, there is wood. Ignore it. And here is solid wood. That is really amazing material to work with woodworking. This is three-dimensional wood. You have different types, finished, unfinished, stained, and whatnot. And here I'm using the 3D Maple semi-gloss. So what is 3D wood? It is actually truly rendering material like this is carved. Pay attention to this edge here. Now I'm going to fillet it. I will want to use a chord length fillet. And you see how it simulates really how the wood would look like if we would break this edge by 0.5 of a millimeter. Very good. Okay, I would say this base is kind of done. To the next thing. So all this can go. Let's show this. This can go. I will show this sketch, and we should work on now the lid. Well, I will turn this off for a second. That makes actually seeing everything a little bit easier. And you can see here how the lid goes down. This whole area is solid, and then it goes over. There's this piece. So how do we start? I would start with a new sketch. Again, this is a new body. Then, to make everything perfectly match, I will project in this and this point. Okay. Then the rest I don't need anymore. I can draw a line. I can draw this one down. I can draw this over. Go to here. Stop. Right click in OK. This we bring maybe to here. Oh, you see how this one is moving. So this point and this point we make our vertically constraint. Is this not horizontal? Oh, there it is, perpendicular. So here that I delete horizontal is just my preference. Right click OK, and then I move this one up. There we are. Beautiful. And here we bring this one down. How long is this line? Let's say 28. I would say 27. This is better. How do we now close this? So check this out. I can use the spline control and click. Oh, you don't really see this one. So let me move this one to there one more time. Click. So 1, 2, 3, 4, and 5. And OK. Horizontal constraint for these 3 spline control point, control cage edges. Here's the spline control point spline. And because I have 3, this is a little bit straighter. And then you have a nice arc. This has to be vertical. So this ends perpendicular to kind of like a line that would be down there, or actually my body. Very good. There we are. And then right click and say, okay, we can go ahead and start sculpting everything. Why this, this goes up and down here. D for dimension, 8.5. Very good. Right click. Okay. Now I can only move this, for example, left and right. I'm improving this design a little bit. There, like this would be really nice to come up. They have this a little bit flatter to also save material, I'm quite sure. Very good. So we do have here a flat piece, and you see how this is arced. So I will draw one additional line here straight up. And this line has a perpendicular constraint. Press D for dimension, and I say this should be, let's say, 3 millimeters. Okay. Why is this very useful? Well, we could now go to solid and revolve and say you revolve around this axis. That is actually step 1. Repeat this one, revolve around this axis. That is step 2. So but please do not join. This thing is kind of solid, that is fine. It can remain that way. And let's hide this one. Right click. I will call this lid end so I know what that thing is. Okay, very good. This lid end later we will join to the rest, and now we have the pleasure to work on the rest. We can perfect a little bit our sketch. This can go over a little bit more, maybe when these points jump, press M when this point is selected, and then it's a tick easier to do these adjustments. There we are. Cool. Yeah, I guess that's the way how it is. Edit the sketch. There's the dimension now. Or maybe make this 28. And that is too high. So maybe 27.5. Okay, a little bit above it, but it's fine. Good. Clunk, 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 clunk. To make things a little bit easier, all this on and off, I will select all these parts in here, put that in, and then I call this one bottom. There, and this way I can, with turning the folder on off, show everything. 3D modeling really much is also about three-dimensional Sudoku. Or playing chess. It's a very tactical game, to be honest. You need to figure out what is the easiest task to do. So I do the slit, and then I do this piece, and then I do that air vent. So let's go ahead to here. Make a new scan. This is a new body, so I will make a new sketch on this plane. I will draw myself somewhere here. A line is easier to start, so you see what I'm doing. I will add 2 points at these midpoints. These midpoints I will make vertically constrained, and 1 point vertically constrained to the origin, because now it's perfectly centered. Right click and OK. This can go down and over. And then this point, I move to here. So the height can be 17. We're building this a little bit simplified. And 20. Okay, dokie. And then how far does this go down? This looks like 7 millimeters. There, 7. Okay. Very nice. Now, going to the solid extrude, I will select this and extrude this over to, let's say, 26. We're going to simplify this a little bit. I on purpose did not extrude this base, because now what I can do, I can go to move command, face, and look, I can snap on here and then just rotate this back. So I'm kind of like adding this angled draft, or let's say 35. Whoopsie, minus 35. Cool. It's like a foam block. We need to also have a space for the smartphone. So I go back to that sketch and then draw a line down, over, and up. Perpendicular constraints, very good. I, on this y-axis, draw a line down. Then I lock that line, because now I can say symmetry and say this point, symmetrical, along this line. Sometimes the section cut does not make these lines clickable. Now I click, and there it is. Can turn this back on. I think it's an interface issue with Fusion at the moment. Right click OK, bring this to there. So these 2 points with D, let's say 13 millimeters, and the height here 14. Beautiful. What we have now is another rectangle which we can extrude. Work smart, not hard. The rectangle is easy to draw, and then the rounded edges, that's just easy to do with a fillet command. Whoa, that's not what I want. Let's cancel. What's the distance here again? That is 13. So that's 6.5. 6.5. There. Cool. Nice and round. Kind of like what we have. Then I could go ahead and round these edges. Now the interesting thing is what we need to figure out or test is how can we round these edges. So that works. Here I would like, with chord length turned on, I would like to have maybe 2 millimeters. That is way too much. Maybe 1 millimeter. What's the difference, chord length and constant? You see how this one gets smaller? Then there you can clearly see that this is wider, this is more narrow, and with chord length, sure, basically these edges are more parallel. Good, that is nice. And then we could say, okay, here, you and you, these we can round really nicely. Yeah, we can neatly push this to 4 in my case. Okay. That gives here nice and big elements. How long is this line? 7. So this piece now I can pull down 7 millimeters, for example. Okay. We do have this sharp edge here. We're not going to fix it. It might also later really sit nearly in the base. To hide this a little bit. Let's put this one down. No, we keep it there. It's all good. Okay, so we do have now half of this model. How do we get the other part? Well, we go simply to mirror. Body, this one across this plane, join command. There we have one piece. Very good. This is kind of finished, so we could rename this the smartphone holder. And the smartphone holder we remove from the lid and keep tools turned on, because now we do have this opening. There have to be 2 dots, by the way, so we need to backtrack. Do we do this there or there? Let's go to here. Here now. No, actually, let's do this there. We select this face and go sketch, go circle there. Let's say 8 millimeters. Very good. This point should be horizontally to the origin, so this only can move left and right. We can dimension this to maybe 12 millimeters. Then I will extrude this one inwards, -5. 7 is the max, so -5 goes in. We bring this over. This piece we cut out of this other part, and look at that. We have kind of like a key element. This was actually a nice exercise to show you how we can move everything around in the timeline. And if we want here, this 1 millimeter of a rounding there, then it's not so boring. Okay, so last piece to work on. That's actually now this element. So that vent flap. We go to a side view. I will turn this one off, go to section cut, and then we can see where this is. I will make a new sketch because again, this is kind of like a new body on this grid. I just clicked and I go down and over and up and back. That should be horizontal. Okay, we can eyeball the position a little bit as we want. This is all good. So, and you see here, we also have this fluid and air vent. Actually, nicely, that is at an angle. I didn't realize that before. So how do we do this? Do here. This one I turn on. No, that's not the one. I need this one. Because I know this somewhat actually in the scan does connect there. Now there you can see that. Okay, so in this sketch, we're going to do the following. I draw a line down, I draw the line over, and press OK. Where's the midpoint? Nope, that is not the midpoint. There and straight up. Then I go project. No, not project, intersect. Intersect this inner face because now I can snap onto it. There. And then this, you see how I can rotate. This is actually pretty useful. And you will see in a moment why. So this body I have, we will now extrude. But please symmetric. It's really a tongue breaker for me for whatever reason. We can go 13 millimeters. This actually goes both ways. Yeah, let's say this way. And from that part, we cut this one out. No, hold on. Let's do a following. I will delete that feature, right click. Then I will show this piece. So here we now go 13 and we cut this. And that also needs the lid end. Okay, beautiful. Good. So, then there we need to make a new revolve, but this time with both profiles selected around here, there, and then we select this sketch again and do the same 13, but this time we say intersect and okay. You see now we have actually the piece that goes in there. That's the main reason. This one we hide for the moment. We want to finish this piece here first. And I will revolve this. And then I show this body. We can cut this one out. That should work, hopefully. Okay, good, thank you. Yeah, all good. Let's check this out. We go to the bottom, shelling, 2 millimeters. Okay, there we are. There's our lid. Join, and we join these two pieces together. Yep, very good, very good. So if we look from below, you can see there is no overhang. Overhang means if we look from the side and turn section cut on, these are all 90 degrees, so we can pull this out. Ideally, they need to have a little bit of a draft. Manufacturing engineer is doing that for us. However, this design nearly is done. The last thing kind of missing to finish this piece here is that needs to have some openings. So a sketch on that ring, I project maybe this edge in. There we are. Let's look from the top. I will do an offset of this by -2. And then I will go to the slot tool. That's kind of cool actually for that. From the center up and over, center up and over, center up and over. Then I will call my tangency constraint and tangency constraint all these arcs onto the that ring. Right click OK. And that ring is a construction helper, so line type construction equal with nothing selected. These are all the same dimension. This one 2 millimeters. There we are. Horizontally, vertically constrained. Oh, we don't need it. Yeah, makes no sense what I was just trying to do. We can adjust the distance here a little bit. You see I'm creating a dimension and then I click on this first one to sample over the value. So when I go to here and say 6, you see the other side will be updated. If I click and click, it tells me, hey, this is a over constraint, but hey, we can create a driven dimension. Cool. It reads out that this is 2 millimeters. Same here. Beautiful. So if I go to 7, that will be 3. Okay. Now we can select the fill, go to extrude, extrude down, or cut through. There we are. There we have the slot. So this piece for the moment is actually done. This is quite hilarious. So that's nonsense. We can select these 4 faces, press delete, and then it's cleaned up. Very good. Yeah, really nice. Actually, I don't know what happens if we select this and bring this over. Okay. Oh, look at that. You have a nice stepping that might even be easier to do. I don't know. Maybe match. So replace face, you to you. It doesn't do it. And the idea was to kind of like fill this area, and then we have a lot of plastic there too. What's actually draft? For those who don't know, there's a draft command somewhere. It's hidden there. Draft. Pull direction. Actually, I forgot now how to use it. Here. Draft is actually nothing else. Like, no, not you. This need to reposition that origin to there. Thank you. And then we add a very tiny radius to it. So that then you see this is angled. So think about 2 molds, male, female. It's easier to pull one out. That's all. But again, that's what the manufacturing engineer is going to do for you. Oh, this is super tight here. That's not ideal. Well, fortunately, we have the sketch and this offset we can change to -2.5. and finish sketch. There. Now we have more gap. Beautiful. Let's do some cleanup. So we fillet this section first, 0.5. Okay. And then we can fillet this one, 0.5. Okay. Good. Right click, fillet, and this one, 0.5. And you see I'm using the chord length all the time. Very good. If we want to be super, we can also do something here for later the lid to easier slide in, for example. Beautiful. Last piece. How do we now design this one? Okay, so let's look back. We do have this here, so that we can revolve. Do not join. So new body, that is good. We have a surface offset, so I can select these surfaces, and for example, I could with this command shrink everything a little bit. So let's say 12. Why is this useful? Now you see you are creating that gap there in between. I will actually keep this one a little bit more flush, but this one here I would like now to move back. That there, I know we need to have a little bit of a gap actually. I'd say 1 millimeter. Okay, cool. All the other edges remain sharp for the moment. All good. This one has to go up a little bit. 0.25. Remember, these radii are 0.25, no, 0.5. 0.25 is half. That's the reason why this matched a little bit. Actually, no, let's undo this because I will show you soon why. So that is fine. And then we can select this and this. Okay. Bring this in. Wow. Hold on. You saw this flickering now. So let's say 12.5. Press enter. Let's go to a top view. Ah, okay, undo, undo, undo. I had the feeling that there was something funny going on. This should be a new feature command. Okay, it does not create it there. Okay, this might be a bug. What do we do otherwise? Well, we can just move that face here. It might be not so difficult to do that. There, okay. If I go to a top view, yeah, you see this works a tick easier. Go to here, we can do the same. Minus 2.5. Okay, good, good, good. And in case this one here makes too much of an issue, here, let's delete it. And we do that with the move command. And this one has to be a little bit bigger. Again, I will in a moment, till I zoom back into where we have to be. Explain. Let's say minus 1.5. 1.5. In CAD, things look really huge. This is a major gap, but keep in mind that's 1.5 millimeter. It's peanuts. Okay, anyway, let's wrap this up. This piece, I would like to isolate, select top and bottom, shell it, let's say 2 millimeters. We'll just go with similar easy values. Then we have that. Here I will round these edges, 0.5, or right click and repeat, 0.5, okay. And then I will select this bottom shell, 2 millimeters. Okay, thank you. Let's take a look at this. This overlaps there a little bit. How do we fix this? We can select that surface and then we pull this one up. And then we join these two. Whoops, wrong tool. Join these two together. And then I select this, and press delete. Gone. There. Kind of cool. Okay, we're making good progress. We are, if I do a section cut at this position, and right kind of here, we need to know to create the joint. So the whole thing can rotate a little bit. Yeah. To do this, I will turn this one off, lit ends. I will go to one edge, sketch on this face. I'm sorry for these jumpy behaviors of Fusion here right now. I will create a ring, 5 millimeters. Okay, so that's our rotation axis. And then I will project this one in. Very good. I will say tangent UU. Then I will draw a line further up over to this thing. Vertical, horizontal, vertical, tangent, or it is already tangent to there. I could press P to project this one in, tangent that to, oh, it doesn't do that. It should have, so maybe I bring it very close to there. So why did I do this? Check this out. So this thing I will now extrude by 1.5 millimeters. I have a new feature down there. I will go create mirror and say feature this. So mirror this feature along this plane. And there it is. Okay, so let's see. It does intersect. Very good. So now I could hide this one, show that sketch, and now I need to select this, and go extrude this one over by, let's say, 0.5. Yeah. And then I select the circle, extrude 1.5. I need to verify one thing. So U to U, that is 1.25. So, oh, that's 1.25 material thickness. So that's really thin. So this one here, in my case, we make 1. Whoops, no, 25. Oh, I fused it all together. Uh, undo. So here, there. So be careful what you do when you see, or what you do and what object you see. It did actually fuse this because it's a joint command to the lid. Okay, so this is better. This is now 1 point. 1.25. Yeah, edit feature. So here 1.25. Now this should be 1 millimeter. So we have 1 millimeter material thickness left. Okay, beautiful. That means if I go to this one, I can fine tune everything a little bit. 0.75 maybe. So I only have half a millimeter of an overlap. That's not really much. Now, again, this is something the mechanical engineer will help us to prototype. Mirror feature, this one over here. Okay. Can I actually mirror both? Okay. Yeah, it did. Beautiful. Very nice. So let's see actually if what we designed also really works out. So here is our piece. I go to move, copy, rotate. There is a circle. Beautiful. Let's rotate this minus 45 degrees. Okay. Go to a side view, section cut, show the lid. Okay, there we are. Yeah, okay, so there, that seems to work. Edit feature. Actually, I have to delete this one. With the section cut, I can then click on that circle and then let's see, rotate. So on the back, it doesn't hit, but you see at the bottom there, it hits. And also here in the front, you see there is an overlap. Again, these are elements then through manufacturing, the design can be perfected. Maybe this has to be a little bit lower. Maybe this is a little bit smaller. There. Cool. Okay. For demonstration purpose, we could, for example, rotate this one up 90 degrees. Because then we can see, oh, it's inside there. Let's press A. Give all these materials. Thank you. There we are. When we right click and suppress this one, we do not, however, have an ability to flip this one up easily. So we can also round this one a little bit. 0.5, 25, a quarter of a millimeter. That's kind of nothing. And we would like to have a piece there sitting. So I create a construction plane, offset it by maybe, I could say 5 millimeters, or we could also extend that piece. So it's for us to decide on there or extend it. Actually, no. Let's go back. This one we delete. Then I go to here, make a sketch. And then we simply create there the piece I want. So I project this one in. Thank you. Then we could use the spline control point. Click, click, and click. And okay. Symmetry, this point in here to there. This point and this point to there. Doesn't like doing that. Maybe I have to move this first. No, this should work. It does not. Huh. Okay. Oh, when in doubt, throw it out. Sure. There's a lot of symmetry stuff going on. You saw that? Let's delete this one. Sometimes that's easier. So let's quickly prototype if that will work that way. Escape. So I pull this out, I pull this out. And now you symmetry along that one. Ah, there. Okay. Note to myself, reading the manual can help. Right click and say display curvature comb. What is this? And I can create a nice flow. For example, this is an elliptical piece. And these endpoints should really be symmetrical to there. Okay, good. Escape. Yeah. Okay. So now you can see this is maybe, getting closer to kind of like an ellipse, but it's not really just an ellipse. And this point to this point, I want it to be horizontally aligned. Okay, so why did I do that thing? So that is good. What's actually the distance? Let's see. We can easily find this by simply drawing a line there. That's a helper line. Let's maybe turn off that other sketch there. D 4 millimeters. That is sufficient. Very good. Then this we can solid extrude up by, let's say, minus 1.5 millimeters. This we can't extrude. Wah. But can we offset this one? Yep, we can fold this into there. Okay, that worked. Yeah, now we can just go Boolean them together, and then this, for example, we can round nicely. And if we want, right click, repeat. We could also round this one, but gentle, small values. 0.5, there. Very good. Repeat, 0.25. Whoa. I'm using the chord length. That's maybe this one was a tick too tricky. Should technically speaking work. 0.01. Okay. 0.1. 0.05. That one works. Okay, here, you get that one. Very good. So, yeah, there we are. We can go A, lid, wooden material. Beautiful. We do have this move command here at the end now, so we might want to bring this back to the end. And let's see, unsuppress. Yep, everything moves beautifully with it. So there we are. This is actually how you can build this ramen bowl, kind of like with a rotatable vent lid, including a wooden handle and smartphone holder, and also the main compartment is shelled out. Now this is now something that could be given now to the engineering, and then I will say, hey, there's a lot to change. Here we can round this also a little bit. There we are, because you remember that scan had this one too. Was the last detail. I kind of forget. No, forgot. Past tense. Perfect. We're done. Nope. Sorry. This one we need to fix. This can be simply a constant. Can make this maybe 1 millimeter. 0.5. Let's make this a G2. There now. This then is nice and round. Now look at that. That's beautiful. It's worth the work. And essentially, the techniques I showed you here in this video really apply to a lot of elements. Is it like you have to make a water bottle and you make the cap with a rotatable water spout or so. It's always the same game. Very good. Peace out.